Good day guys, and welcome to lecture 2 of this particular tutorial series. So the tutorial series is structured programming with Vicol. We are going to learn about structured programming using C program. Now structured programming is a programming paradigm that is kind of like the basics of programming, because if you really understand how structured programming works, then you can advance and start learning even more concepts or more paradigms in programming. Now let's dive into the actual basics of programming, because in the last tutorial I explained how you can download the IDE you're going to be using to write a C program and introduce you to the environment for writing C program. But in this video we're going to kickstart by settling all of the basics of C program. So I promise you that at the end of this tutorial, which is lecture 2, you're going to understand the pure basics of C program, and it will be a prerequisite knowledge for you in lecture 3, 4, and all of the other future videos. So let's dive into the video. So on the schedule I shared, today we are going to be dealing with general overview of C program, intro to the basics of C program. We are now going to be discussing headers and preprocessors, constants, main function, comments, return statements, and displaying output in C. So now let's dive into it. As you can see, we have our workspace set up here, and we have a file we created then, which was in lecture 1. Let me just go now to create a new project and name it lecture 2. Right, click on new project and then console application like I explained. Then you go next, and then we are doing C and then lecture 2. Okay, yeah, so and then next and finish. Right, so now you can always switch between your projects here on the left hand tab. Lecture 1, this is my main.c file, and lecture 2 I can open another main.c file right beside it. So let me just close this now. Yeah, so first we're going to be doing some explanations so that you can be able to understand the concept. Like I promise, this tutorial is one that I want to actually take my time to explain how these things work. It's not rocket science, it's very easy to learn. You just need to understand these things from what I'm going to be teaching. Right, so I actually have a document which is currently a soft copy, and I don't know, I'm planning to either make it a hard copy and send to you guys, or distribute it like this as a soft copy. But once I'm done finalizing my decision, I'll let you guys know. So guys, I want you to know something about the structure of a C program. The structure of C program is divided into 6 main components, right? 6 different structures or 6 different parts. And if you can understand all of these 6 different parts, then it's like one of the very first knowledge you know that you have about C program. So now the very first section of C, you can write it here in our program so you can follow along. Let me comment this out. You guys will know what comments are later. Okay, let me just do what I have to do. So first we have documentation. Okay, sorry. Next we have link section. Next we have definition section. Next we have global declaration section. Sorry. Next we have main function, and next we have sub program. Oh god, we have subprogram section. Now it's not actually difficult. Now let me explain. Now to write a C program, or the structure of a C program, allows us to group all of our program or the entire part of our code into at least like 4 of these sections. Right, not every time you actually have 6 of all these options, but at most, averagely, you have about 4 of these sections in your program. Now let me explain. Now the first section is called the documentation section. Now this documentation section is, as the name implies, documentation. What does documentation means? You want to document something, you want to write something down, you want to drop necessary information, right? So that's basically what the documentation section is for in C program, right? So documentation section in C program, as you can see, I listed it as the first. Is actually the first thing to do in your program. Now, what does it do? Documentation section in your C program is a section at the very top of your program that allows anybody know, or any other programmer, just like me, or if you take up this code tomorrow and you want to read about the code, at the very top of the program is where I'm going to document and write my own important information to you that is going to be reading this code, that okay, this program is a program to calculate the mean of 5 numbers. And that is what we call documentation. Now, documentation basically at the start of every C program is just to let any other programmer know that this particular program does this particular function, like has these particular features embedded in it. All right, and most times documentations are not most times every time, sorry, documentations are always written in something called comments. Now, what are comments? Comments are basically, as the name implies, comments. You want to give an idea about something. Still more like documentation, right? But comments in C program or most programming language are a way for developers to communicate with each other without the computer getting confused. That's like a layman's term or a layman's understanding of what comments are. So you want to communicate with another developer that might potentially see your code tomorrow, but you don't want your computer to see that particular code and run it because it's going to run into an error. Now, all comments are just a block of code or a line of, not code actually, a line of your code that your compiler can actually see, but it does not run. It means it interprets it as nothing. What do I mean? Now, this particular thing, if I want to run this code now, I'm going to see that the computer is going to give me an error. Like I told you, we have this function, this symbol here that says build and run. If I click on build and run, you see it shows this red flag here. It means from the beginning of this code, there's actually an error. Now, what's that error? Like I said, writing your code like this program is a program to calculate the mean of 5 numbers. It's trying to tell the computer that okay, from this first line, the computer wants to read this line of code as something that it should run, right? But then this thing that you wrote here was not for your computer to read, right? It's for human being to read. So in order to make it such that your computer or your compiler, which is going to actually read the program, can just read it, but it's not going to run it, you just need to add 2/ in front of it. And as you can see, the color changed from black to what? To gray, or I don't know, light purple, or light purple, I guess. So now what this means is that what? All of the content after this 2/ is going to be seen by your computer, but it's not going to be run. Alright, so you're trying to tell your computer like, okay, just like the story of the forbidden apple in the Bible. Let me just use that as an example. So now all of these things are blocks of code. I'm telling my computer that what, wherever you see 2/, everything after the 2/ is forbidden for you. What do I mean? It's not for you, it's for somebody else who is what? A developer. So after your 2/, every other thing that comes afterwards, your computer is going to ignore it like it's not a piece of code, and then it's going to move on, reading all of the codes after it, right? So now let's build and run this and see if we still get that error. Now, as you can see, the error is no longer in line 1. Line 1 is successful. Line 2 down to line 11 where the red flag is, and that is because of what? Documentation here also. All of this I listed here, like I said, they are for you to see and for me to also see because I'm teaching you, right? Not for the computer to read. So if I want my computer to omit this and not run it as an actual code, I just need to add 2/, 2/, 2/, so that my computer knows that anything after the / on that same line is not going to be run by it. It's just going to omit it and go to the next line. Now, as you can see, it's kind of getting stressful for me to be adding 2/ to each of these. Imagine there are like 100 lines of things I listed here, and then I don't want my computer to read it. Now, there's actually another way you can also do this. If you want to comment multi-lines, right? Like I said, doing this thing is actually called commenting. You understand? You want to comment in the sense that what? You want to add something that you don't want your computer to run because it's for other programmers like you, just for people to see, right? Now, if you want to do multi-line comment, all you need to do is /**. That's the opening part of where you want to start commenting. So when I do /**, I'm telling my computer that anywhere you see /*, right from whatever is after the asterisk down to where you will see an asterisk and a // don't run whatever is in between these two things. As you can see here, forward slash asterisk opens my comments, and then asterisk and the forward slash basically closes my comments. So it's telling my computer that what, from line 11 where the forward slash and asterisk opens down to the line 16 where my comment closes with asterisk and forward slash, I don't want the computer to read all of what is here. So now we are very good to go with our program. Let me build and run this, and let's see if we still have the error. As you can see, our program compiled very well, and then we don't have any error in this code. It actually brought our results. Sorry, let me cancel this and build and run again. My PC is taking time to load. Okay, it has loaded. Hello world, as you can see. Now, this is because what? We actually wrote something here for us humans to see that we don't want our computer to read or run, and then what? We just opened our comment here and then we closed it here. So that tells our computer that what? Everything in between here is not a machine, readable code. It's not something you should read. You should just omit it like it never existed. So that is what comments are. And you document by using comments. Now the next section after your documentation section, which is this one at the very top, is the link section. And the link section, what you basically do in a link section of a C program is to, like the word imply, link section. You want to link different external components, you understand? And that is where we use the keyword #include. Now this particular PDF I said I wrote, or I actually did already, is something I would employ us to actually read before, or like during the course of this tutorial, so that you understand all of these keywords I'm saying beforehand, and then you just flow along. But still, I'm going to be explaining them in each of the videos. I'm going to be talking about them. Now, #include basically is a keyword. Keywords are basically just the words that a particular programming language recognizes. You understand? It understands that, okay, this is my word. Let me say the word thank in English. English recognizes thank you or thank, but then in French, if you say the word thank, it doesn't mean anything in French. Whereas if you say the word merci, it means thank. I don't know if you understand what I'm trying to say. So #include here is something that C will see and they'll be like, okay, yes, this is, you're trying to talk to me to do something, right? So keywords are basically just, those words that each programming language recognizes as their own, something that belongs to their own grammar. You understand? Like it can be found in their own dictionary, just like I explained for English, saying thank or thank you. And then if you say thank you in French, it doesn't mean anything literally in French. But if you say merci in French, it means the narrative, like the translation of English. I don't know if you understand what I'm saying. So #include here, once a C program sees, once your compiler sees the word #include, you understand that, okay, you're trying to tell me to do something. Now what the #include basically does is what? You want to link, or you want to like include something that is not in your program so that you can actually use that feature. What do I mean? Now with the #include feature, you can actually link different header files. We call some things header files in C program. Now what header files are basically just some components or some libraries. You understand? You know what libraries are now? Some components or some libraries that actually does something, but using the #include, it means you have this library that does this function, but you want to like include this particular library function into your program, so your program can also use those features or exhibit those features. And that's basically what this is. So for link section, you actually use it to link libraries and header files, so that you can be able to use the functions or the properties those things have in your own program. Now let's say, let me give you a literal example in okay, now I'll give you a literal example. Some kind of websites that you see that you want to create an account, and then you see something like sign in with Google or sign up with Google. Now that's like basically what we can use to relate this link section. Now more like you're saying, okay, if without this link section, it's more like you want to register with your username, password, first name, last name, and the likes. But once they now do something like #include sign in with Google, it means Google has your account details. That's your first name, your last name, your email, your date of birth. Now including Google Account Manager into a particular project means that what I want to access a particular person's account details, and then use all of those details in my own project. So that's basically what the #include actually does, and they are going to be in the link section of your program. So after you document your program, the next thing you want to do is add your necessary links using the #include then less than, sorry, yeah, the less than symbol, the name of the library dot h, and then the greater than symbol. So stdioa means standard input and output. Then the dot h it stands for like header file, which I talked about before, the library. And then stdlib means it wants to include the C standard library. Dot h representing it is what an header file that is to be linked. Now after that, you have something called the definition section. Now definition section is a section or a part of C program that allows you to define things that you want to use in your program. Variables and constants are the two things, the perfect example of things that are actually defined here. Now, as you all know pi to be 3.142, and we know the gravitational constant g, the small letter g, to be 9.8, sorry, yeah, 9.8 and sometimes 10, right? Now, if you actually have a project that you want to work on, and probably throughout the end of the project, from the beginning to the end, you know that pi is going to be 3.142, and probably you're dealing with a project that has a circle project, you understand, that you always need to call for the value of pi. So instead of having to always do 7 times 3.142 times 7, and another place again you're doing 2 times 3.142, you understand, like repeating the 3.142, you can come to the very top of your project and then define pi as a constant, so you can always use that value of pi every part of your program without changing its value, and it's always remain the same because it's a constant. So all you need to do, like I said, we need to define our constant. So use the keyword hash define, then space the name of the constant. So now we are using pi, for example, pi, and then the value 3.142. So now this means that what, anywhere in my program I want to use the value for pi, I just need to do what, call pi. So if I have a probably calculation that says area is equals to radius times pi, I just need to do r asterisk then pi. Now what my program is going to do is what, because it already knows from the very top, reading the program from top to bottom, like every programming languages does, or most programming languages do, it actually saw that what the value of pi is what, 3.142. So in any part of my code where I'm going to be referring to probably multiply by pi, add by pi, subtract by pi, divide this value by pi, is automatically going to use the value 3.142. So definition section is always after the link section, that allows you to define your constants that are going to be needed in your program. I can also define another thing here. Let's just say hash define g, and the value is what, 9.80, and like that is how simple it is. Sorry, 9.98, 98 or 80, yeah, 9.8, let's leave it that way. And yeah, that is all for the definition section. Now there's something called the global declaration section. The global declaration section is a part of a program where you want to declare variables that you want to use in the entire part of a program, just like constants. But instead of defining constants, instead of defining variables, we have them defined like this. To declare variables, you just need to first of all know the type of variable is going to be. If it's an integer, like in numbers 1, 2, 3, 4, 5, 6, 7, they're integers, and say int, and then probably, okay, let's say want to create a global declaration as in I want to create a variable, right? A global variable saying year. Now this is the new year 2024. Now I don't want to always like repeat 2024 in every part of my code whenever I need to call the year, right? So what I can just need to do is what, create a global variable called int this year, and then I'll say is equal to what, 2024. And that way, whenever I want to refer to 2024 in my program, I don't always need to type 2024. I just need to type this year, so I know the current year we're in. Now the next section is actually called the main function. Now this is like an interesting part for me because it's really not much to explain and it's very straightforward. So now this is, as you can see, main, then the two brackets in programming languages, most times in programming, symbolizes function. So what's interesting about the main function is that what, anything written outside of the main function is not going to be run. All right, so your program actually runs what is inside the main function. Just put that in mind. After all of these sections that are before the main function that I listed here, like your documentation section, your link section, your definition section, and global declaration section, the main function is what is going to be executed. The result you are seeing when I was running this thing, I was showing hello world. That's because what, this print hello world is inside of the main function. If it's supposed to be outside, then it's going to run an error, or it doesn't run, you know, hello world to your screen. Let's run this. As you can see, it generates an error, right? Because what, it doesn't recognize this as something you should do, since it's not inside of the main function. Now remember, anything you're going to be doing in your program is always going to be inside of the main function. So you want to do calculation of maybe 2 times 2 equals to 4, I want to like c equals to 2 times 2, and then you want to print your c, right? Or you want to do a calculation for calculating the sum of two numbers, the mean, whatever you want to do, it always has to be inside of the opening of this curly braces of your main function, and it must not pass, the closing of the curly braces of your main function. So now if you can build and run this, you're going to see that it's not going to have any error anymore. Yeah, it has printed to the screen, right? So what I'm trying to say is what, anything you're going to be doing in your C program, you always have to reference it to your main function. If you don't put in your main function, your program is either going to generate an error for you because it didn't recognize it because it was not your main function, or what, it's not going to run that particular thing at all, and then you'll be confused. Why is my program not running? Why am I not seeing this? Why am I not seeing that? That is basically because what, you did not, in a way or the other, include it in your main function. Now the last thing I'm going to be talking of is about the subprogram section. Now subprogram section is actually a way that, like I said, the only function here in your program is the main function. This int main function. Now imagine you want to like put your codes into different things. Like you want to create something called functions. Now functions are just basically a block of code that perform a particular task. Alright, a block of code that perform a particular task. They just do one thing, or you can actually let them do more than one thing. But then you're like grouping your code so that you don't like have everything jam packed in just your main function. Now that's what we call subprogram or functions in C. Now to create subprograms, just the exact same way you created your main function, which was int main and then curly braces, you can also do, let me say, int age. All right, and what I just want to do in my int age is to return, let me say this is 2024 24, right? And now let me build and run this program. Now watch, let me build and run this program. Now I want to return 24 to the screen, right? And I'm saying int age, right, return 24. Now let me build and run. Now guess what, the program is actually running, because yes, it's actually correct. We didn't make any error trying to build the program. But guess what, as you can see, it only printed hello world, just like as if we never added this function right here. So like I said, subprograms are just some other part of your code aside the main function that actually does some specific task. If not one, then maybe more than one task, but they are just not in the main function. Now, and I remember saying to you that you must always remember that your main function is actually what your computer runs. You understand? So now we created a function here called age that was to return 24, but we ran our program did not return 24. Now what happened? That was because we never related this age function in our main function, so our program never knew that it was something like an age function. It just knew it was there, but it didn't know it was part of what we wanted to display. So what we can do now is to reference our age function in our main function by just saying, sorry, what we need to do is come here in our program and reference age function, so that when our computer does line 13 and it prints hello world, it will come to line 14 and say, okay, it's meant to run age function. That is basically what line 14 is saying. Age, then opening and closing your round brackets, is trying to tell your program that go and read the age function and come back and display whatever is meant to, like, come back and do whatever is meant to do, right? Because here you currently have just one line inside of your age function. You can have up to 100 lines in your subprogram. You can create a function with over thousands of lines. So what your computer is going to do is, once you get to that particular line where you called it, like this line 14 where we called age, your computer is going to go and do all of this task that is inside of these curly braces, and then do whatever is meant to be there. So you're going to return 24. But we also run this right now. We're not going to see any result. because return is not a way to print statements in C. Which brings us to the last, lecture for today, which is about the return. Displaying output. Now, to display output in C, you use the word print F. All right, and I'm actually going to be doing something now, which I'm not going to be teaching you exactly why it works like that, because it's a content for the next lecture. But to print this age function now, because an age is an integer, as you can see, we're returning 24, which is a number, an integer. We need to do this right here, %d, age. Now, what this actually means is what I'm going to be explaining in our next lecture, so you should not miss it. But running this now is absolutely going to print 24 after printing hello world right here. So now let's see what we have. So it's still loading. Program is still loading. As you can see, we have hello world on the first line, like we told it to do here on line 13, and then the next line did what printed 24, which is this line 14. Now, like I said, we could only print 24 because what we indirectly, told the program in line 14 to what print something, which is a way of outputting words or outputting whatever, which is a way of outputting things in C. So I told my program, okay, I want to output something. What do I want to output? Go to age, do what I wrote in this function, all right, which is basically to what just return 24, and then come here and what display it. Display it is what print F in C, and that is why our computer could first display hello world and then run this line 14, which I told it to print something. But what should it print? Print what? Whatever is in my age function, which is basically just to what return 24. Now that's basically how you print things in C and the structure of a standard C program. Now, what this return 0 stands for is just to like tell your computer that what you are done with your program, and it should return back to your operating system. Now, what that means is that what after you've written all of the lines of code and you add your return 0, anything after your return 0, as long as it is not an error, is not going to run. Now let me say after my return 0, let me do printf, let me say another hello world here. Now let's see what's going to happen. Now let me build and run this program. So I think I still have it running. Still have the previous one running right here. Sorry. Previous one is still running. Yeah. So now let's build and run this program now. And let's see if it will print hello world once or twice. Alright. So it's running now. And as you can see, it printed hello world, then 24, and then it ended by showing this process return 0. So after your return 0, I basically tell your computer to what? Terminate all operations, like just stop working and return back to the operating system. That's basically what return 0 actually means. So once you do return 0, your computer doesn't even want to hear anything at all. You don't want to brief for anybody. Your computer doesn't want to do any other thing, and it's just going to stop it's just going to stop executing all other commands below it. Alright, so that's basically it for this tutorial, guys. And like I said in the beginning, most C programs does not always have all of these components as it is. Sometimes you can write your program and you don't even need to have a sub-program, so that way you have 5 out of the 6 components. Sometimes you may write your program and you don't have constants to define. Probably you're not dealing with much calculations, and then you're left to just like 4 out of 6. Sometimes I also don't need global declaration, so you're left to what 3 of them out of 6. Alright, but it's always important and it's always useful for you to always structure your codes this way. If you actually if need be, if you're going to be using sub programs, then do it this way. If you're going to be adding constants, then definitely it's going to be after the link section. Right, so I hope now that we've concluded this tutorial, you can actually understand the whole concept or the whole general structure of a C program. First of all, we have the documentation section, which is just basically writing what about you're just basically writing what your program is about. All of these things are here. What they are doing is what you're going to put in your first line, which is the documentation section. The second section is your link section, where you want to add some features, some libraries that are not in your program. You want them to you want to add those libraries to your program so you can use them to perform other additional features. Now after that, you have your definition section. Using the keyword hash define, you can create constants that you can use in the entire part of your program, though we didn't use them in this program. Now after that, you have your global declaration section, which you just declare, a variable globally that you can use in any part of your program. And then you have the main function, and immediately after the main function, you have your what? Sub functions, which allows you to create other blocks of code little by little that you can always reference in your main function if you want them to run. All right, now that's basically for this video tutorial, guys. Now this tutorial was actually a long one, just like the previous one, but come next and next tutorials, they're going to be actually shorter than this one, because these first two lectures are actually the basics, and even the next one after now will actually also be a little longer, but then it's for your own good. I'm actually doing all of these things to take my time to simplify all of these things the best way I can, and also give real life examples so you can assimilate and understand what exactly is going on. Now thank you very much for watching, guys. Like this video if you actually found it useful. Comment down below if you have any query at all. I'm always here to respond to you. Share the video to your friends that you also want them to learn how to code in C, to learn foundation of programming, which is structured programming. And yeah, do also subscribe and stay tuned for the next lecture. I'll see you guys in the next.